Welcome back. And we are ready to start the third module of this course. We've completed angles and we've completed polygons. So now we're up to circles. And I'll click onto that tab. And if you have the notebook, you should have that tab also. And we're going to just slide on over to page 1. And on this page, I want to talk with you just a little bit about some circle terms. Some terms that you need to know for circle work. Okay, so I'm going to zoom in one time here. I won't keep zooming in and out unless it's absolutely necessary. So the anatomy of a circle. The first thing we need to do is to mark the center of our circle. So it's right there. And then I'm going to call this point R. And I'm just picking, actually let's not use R because that's going to be confused with something else. Let's call this point M. So circles are named by their center point. So we can call this, its name is circle M. Okay, circle M. So any circle is named by its center point. And as I'm looking at this, that's really not the center. So let me adjust that just a little bit. It's more like right there, I guess. Again, I didn't do a very good job of drawing the circle, but we have to get as close to that center point as we can. So we'll set it maybe a little bit up right there. So first thing you need to know is how to name your circle. Then let's do, if you have colored pencils, this is a really good time to use them. Let's go ahead and draw in a line segment that runs from here to here. Okay, and that is called radius. So let me give you the definition of radius. Radius is a line segment that runs from the center to the edge of the circle. Okay, so radius is a line segment that runs from the center to the edge of the circle. That is a very important term that we need to know. You will see this a lot with circles. So I'm going to pick up a red color and draw another line through the center that goes from edge to edge. And this one is called D. Diameter, and that did not write a D. Okay. Diameter is a line segment that runs from edge to edge through the center. That's important. It is connected to the center. Okay, so diameter is another term that you definitely will need to know. We will be using radius or diameter in every problem we do. So it's important to understand the difference here. And if you notice, it takes 2 of the radii to make 1 diameter. 2 of the blue lines would equal the red line. So radius and diameter are linked very closely together. Okay, let me show you yet another one. I'm going to use a green color on this one. Suppose I drew another line segment maybe down here that went from there to there. Notice that this one does not pass through the center. It's just a line segment that goes edge to edge. This one is called a chord. So chord is a line segment that runs edge to edge, but it does not involve the center necessarily. So sometimes it doesn't touch the center. So a chord can be anywhere on the circle that's going edge to edge. And that's not usually going to be an issue, but for those of you going on to college, I think that's an important word that you need to know. I don't want you to get to your college class and feel like you don't know what's going on. Okay, a couple of more terms. You already know area is the number of squares that it would take to fill a space. And we've talked about you cannot find a perimeter of a circle because it doesn't have angles. So instead of perimeter for a circle, you find what's called circumference. So let me... Okay, circumference is the distance around a circle. I'll never forget, I was in a high school class, and the problem was talking about a tire on a car that was turning, and it wanted to know how much distance was covered each time the wheel turned. And that was absolutely blowing my mind. I just could not grasp what they were asking me to find. And then the professor or the teacher helped me to understand that circumference. What is the distance around that wheel so that every time it turns one full time, it's putting that much distance on the road. So I always try to mention that experience in case you get a question about a tire turning. It could very well be circumference if you do. And that one gave me a lot of trouble, so I try to throw that in when I can. So you have now the anatomy of a circle. This is circle M. Again, circle M is named by the center point. Whatever that point's name is, you have circle M. You also see radius and diameter. Okay. So let me show you one other thing, and I need to probably draw a circle to do this. So let me I should have put this in, and before I print your workbook, I will go back and put these in. So you will see these on your workbook. That is not a circle. This is the tough part, is getting a perfect circle on this thing. And that looks pretty good. So let me just get a copy and I won't have to keep doing that. Okay, so looking at this particular circle, what if I tell you that radius, get a mental image of radius now, that radius is, let's make this one an easy number to work with now. Let's use 5. Okay. So radius is 5. What is diameter if radius is 5? Well, remember diameter goes all the way across. So that would be another 5. diameter would be 10 if radius is 5. So this is how they will show it to you. Radius is 5, diameter is 10. Okay, let's try another one. What if I tell you that in this circle, let's use red just to distinguish the color. Maybe I give you this dimension, and it does pass through the center. That's very important. And I tell you that that dimension is 30. Okay, so radius we don't know, but we know diameter is 30. So to get the the radius, what would you need to do? You need to cut the diameter in half. So 30 divided by 2 is 15. Radius is always smaller than diameter. If this is a room, your diameter goes door to door across the room. The radius only goes to the middle. Okay, here is another one more. And I want to do one of these with a decimal so that you can see that it's not always easy to see. Not that the first two are, but they're easier to see. And this time I'm going to use orange. So let's say that we go this way. And we make that the center point. That's so very important. And this time I'm going to use 6.95. So you have to ask yourself, is that the radius or the diameter? And it is the radius. So R is 6.95. And you multiply that times 2, and I'm going to need my calculator because diameter is double that, and that's 13.9. Again, I just said 6.95 times 2 to get the diameter. So please practice with that. Even you can draw yourself some circles and practice figuring those out. But you need to really be able to distinguish between radius and diameter. Okay, one other thing when you're working with circles, you have to know about pi. And this pi is spelled P-I. It's actually a part of the Greek alphabet. So if you read and write Greek, you will recognize pi as one of their alphabet characters. And pi is this symbol. You make a little swirly thing, and then the two lines at the bottom, and that is pronounced pi. And for us, pi is always going to be the decimal 3.14. Okay? Now I want to show you where pi comes from. I will only do this once. I'm not going to do this every time we use pi. But I want you to understand where pi comes from. That's what the word derivation means. What is the derivative or the root of this concept? And really what I've done right here is incorrect. I should have said that pi is approximately 3.14. Because pi is exactly 22 over 7. It is a fraction. Okay? So if you're in a class and they want you to use the exact form of pi, you need to use 22 over 7. That is the exact form. If you're in a class, most classes just use 3.14, which is an estimate. And I'm going to show you where that comes from. But just realize that the 3.14 is an estimate of pi. So your answer won't be exact, but most professors and tests will use that version. So here's where it comes from. This fraction literally is saying 22 divided by 7. And so let me go ahead and write this out over here. 22 divided by 7. And notice that I am making a very long line up here because I've done this many times in my life and I know I'm going to need that very long line. And we're doing divided by 7. So this is long division that you may have hated like I did in school. But let me see if I can help. And I am going to zoom this time in on this problem so you can really see what I'm doing. Okay, the first thing I need to do is try to take 7 into 2, and that won't go. So 7 into 22 goes 3 times, and 3 times 7 is 21. So I subtract and I get a remainder. And my teachers always said, you need to keep trying. Let's see if we can get this to work out. So I would add a decimal and 1 0. Okay, and extend this over a little bit and bring this down. And so 7 into 10 would go 1 time, and I get 3 left over. Teacher said, you know, let's keep going. Let's see if we can get this to come out evenly. So I would add another 0 and drop it way down here. And so then I'm doing 7 into 30, which is 4 times. And 4 times 7 is 28. And then I subtract and I get 2. And teacher says, I want you to try at least one more time. And by this point, I would be getting really frustrated, but that's what I had to do. I hated long division. So, okay, bringing a 0 down. I still hate long division. And I don't know, you can tell why. I didn't mean to put that there. I meant to put it right there. Sorry. So 7 into 20 is only going to go 2 times, and that's 14. And by this point, I'm still getting a remainder, and I'm really getting frustrated here. I'm very tired of doing this problem. This decimal will never end. It doesn't matter how many zeros I add and how many times I do this, it is never going to end. It would keep going forever. So it's going to keep on keeping on. But do you see in this particular problem where pi comes from? The 3.14 is right here. And it's not 3.15 because that 2 there is not big enough to round up. So for us, we're going to say that pi is approximately 3.14 because it's not even. It's not an actual finishing, terminating decimal. So let me show you the calculator answer for this. If you type in your calculator 22 divided 7, you are going to get a very ugly answer. You get 3.142857143, and then your calculator just runs out of room. So you can see that my problem was getting there. I got this far, but then I stopped because I ran out of room down there at the bottom. But if you kept dividing it on out, you would get that number and then some. But for us, the point that I'm trying to make, when you need to use pi in your problem, we're going to use 3.14. Unless we're told otherwise, we will not use the fraction. We'll just use the 3.14. Okay, I'm going to stop this video. I'll see you in the next one, and I'll teach you how to do circumference and area, and we'll be done with circles.